A rational expression is said to be simplified when the numerator and the denominator have no factors other than 1 in common. To simplify a rational expression that contains variables, we use the same process we would use to simplify something like 25/60ths. We're going to break the quantities down into factors. 25 can be broken down into 5 times 5. 60 breaks down into 5 times 12. Then, using the fact that anytime we have a factor or a number over itself is equal to 1, we can cancel out, and using the property for the identity of 1, we can remove that factor of 1, leaving us with our simplified reduced form for this rational expression. Here, we're looking for common factors. Considering the integers, each of these numbers has factors of 7. 7 divided by 7 is 1. 21 divided by 7 is 3. We have a common base over itself. We can use the quotient rule and subtract the exponents. X to the 4th minus 1 will leave an x to the 3rd in the numerator, and that factor of 3 when we reduce the integers. For our reduced form for this rational expression or simplified form. Here in this example of a rational expression that can be simplified, what we have is a common base. The base happens to be the binomial x plus 3. We'll use the quotient rule where we take that common base and subtract the numerator exponential power minus the denominator's exponential power. 4 minus 3 is going to leave us with x plus 3 to the first power, or simply x plus 3. Some quotients or rational expressions involve a little more factoring, and in this case it's factoring of binomials to see if we can reduce them. The only time we can reduce is if they are a factor and connected with multiplication. The definition of a factor. Here it might be tempting seeing an x squared over an x squared, but it is not a factor because the connection here is not multiplication. In this particular case, it's subtraction. So first, factor a rational expression, and if we factor the numerator, we find that it factors into the following two binomials, and we can check with FOIL to verify that that is the correct factorization. The denominator factors into an x minus 3 times an x minus 1, and it's only now at this stage that we can cancel out factors that are equivalent to 1. And that occurs when we have the same factor in the numerator as the denominator, which here we have x minus 1 over x minus 1 is equal to 1, leaving a final value of x minus 2 factor in the numerator and an x minus 3 factor in the denominator. Parentheses are optional here, but we're done with simplifying this because this factor is not the same as the factor in the denominator, and only if it was a factor connected with a multiplication would we cancel out. Some factorization, as we know, starts with factoring out the greatest common factor. So before we simplify, we need to factor the polynomial in the numerator, and it involves a greatest or largest common factor of 3x, leaving x squared minus 4. In the denominator, the greatest common factor is 6x. Factoring out a 6x from each term leaves x squared minus 4x plus 4. And we could simplify here, but I'm going to hold off and do this all in one shot. I'm going to continue with the factoring first. There's two terms left. A binomial, is it a difference of squares? And it does, if you go through the process, meet the criteria, and it factors into conjugate pairs of the square root of the first and the square root of the second term, one being a plus and one being a minus. In the denominator, we always have to be sure we include that largest common factor. And then here we have a three-term polynomial. First question would be, is it a perfect trinomial square? And it does meet the criteria. The first term is a perfect square. The last term is a perfect square. Square root of 4 is 2. Multiply the square root of the first and last together and double it. Gives us that middle term. And so this will factor into the following two binomials. Now we can simplify by using the identity property of 1. Anytime we have the same quantity over the same quantity, and it's a factor, and these are all products of these factors, so we will cancel out an x minus 1 over x minus 1 since it's equal to 1. Likewise, an x factor in the numerator cancels out an x factor in the denominator. And 6 has a common 3. 3 divided by 3 is 1. 6 divided by 3 is 2, leaving the x plus 2 factor in the numerator, since we have 1 times that quantity. And in the denominator, we have our integer of 2 times that binomial of x minus 2, the factor remaining there in the denominator. Here we have our simplified version of the original rational expression.